Later rates. I warned you that this moment was going to be coming. This is where you're going to take the derivative of x and y according to time if something is changing. So in these problems with related rates, it's not uncommon to have x primes and y primes. I did. Thank you, Orrin. All right. So x primes and y primes. That's what we're going to work on today. Related rates means that when time is going on, time marches on, two things can be happening at the same time. Okay? For instance, what's a good for instance? For instance, I don't know. I don't have a good for instance right now. Oh, I know. A ladder is up against the wall. Have you ever seen Christmas Vacation? Ladder's up against the wall. And all of a sudden the ladder starts falling down the side of the house. Instead of going back to the tree, I'm going to go down the side of the house. Well, the distance from the top of the ladder to the ground is changing. So if you had the ladder, let me close that. If you had the ladder up against the house, this is falling at a rate, isn't it? What else has to be falling? Or what else has to be moving? Yeah, the bottom of the ladder has to be going out. Is the length of the ladder changing? In the movie it does, but in this case it's not. So that's a constant. But that's how two things are changing according to time. The x is changing and the y is changing. Yeah? Well, then it could change. And that would be all three things would be changing. So in this case, you could have a b prime and a prime and a c would stay the same. If c was changing, you'd have a c prime. Any formula that you have could be changing according to time. More than one thing changing, more than one prime. And that's how the rates are related. How are they related? In this case, they're related through an equation. A squared plus b squared equals c squared. And they're related through that equation. So the x primes and y primes might be going out the window. You might have a, b's, and c's running around. But remember, they aren't going to give you the equation and the problem. You have to come up with the equation on your own. That's the fun part. If you don't know the equation, you can't start. If you can't start, you can't have any fun. If you can't have any fun, you can't learn for the test next week. So related rates. Now I'm going to have to change that test. I looked at it. It's too easy for you guys. So we're going to have to ratchet it up a few notches. Some people already are getting a D. So let's move on. All right. This isn't, you don't really have to write this down. Some of this stuff is up here in case I'm gone. This is before the definition of videos and WMV files. So if two things are moving, you can always equate them according to time. That's the big key, time. If I'm going to take the derivative of y, I said that was y prime, didn't I? Y prime equaled dy dx, didn't it? I took the derivative of y with respect to x. How's that going to change if I take the derivative of y with respect to time? Instead with respect to x with respect to time, how's it going to change? Okay, an awkward silence is usually when somebody gives me the answer. If I take x out of the mix and put it in time, then y prime would equal dy dt. There. That's the derivative of y with respect to t time. Does that make sense? Okay. What is dx over dx equal to? The derivative of x with respect to x is equal to what? 1. It never shows up. What is dx dt equal to? The derivative of x, and how can I write that? X prime, very good. See how dx dt equals x prime? Why? Well, because dy dt equals y prime. What's t? Time. This just tells somebody, that x is changing. This means x is changing. This means that y is changing. And how are they changing? With respect to time. As time marches forward, how are they changing? Is one getting bigger? Is one getting smaller? If so, how fast? That's a rate. The rates are related by time. Okay? Ooh. Does time have to be accounted for in an equation to take the derivative of it? No, it doesn't. It doesn't have to be in there. You just have to know it's changing. That's kind of good. So, suppose, x equals, and we did this, y equals gt, and since x and y can be expressed in the equation, that's how they're related rates. We just talked about that with the ink that just left. Okay? They're related according to time. So, here we go. dx dt equals f prime of t. We did that. I called it also x prime. Don't worry about the f prime of t. X equals f of t, then the derivative of the equation will look like one of these. This is going to equal some rate. And I usually call that rate x prime. Oh, here's something. Let's go back to the ladder problem. If you had a ladder C, and it was sliding down this way and sliding down this way, c squared equals a squared plus b squared. Is C changing? Let's say it's not one of those fancy ladders. Let's just say it's a wooden ladder, 14-footer. It's not changing. So what's the derivative of c squared? The derivative of any constant is going to be 0. Let's put on your implicit differentiation thinking caps. And what would be the derivative of a squared if you were taking it with respect to time? To a prime. Nice. What would be the derivative of b if it was changing? If this is b and this is a or whatever. What would be the derivative of b squared if it was changing according to time? Yeah, 2b b prime. What would b prime actually equal? It would actually equal db over dt. The change in b according to time. What would a prime actually equal? dA over dt. How a is changing according to time. All right. I think we're getting somewhere. We'll find out where in just a minute. All right, that's good. As implicit differentiation, apply the chain rule to expressions other than x and y with respect to time. Nice. You can read that. And here we go. Our first big time problem. I'll give you a minute to write this down because I don't want to start until you're done writing. I'll wait for Mark to get done writing it down. But he's pretending to write. By the way, Mason, if you're listening to this, I hope you did well.
Yeah, go Mason.
Quiet, Orrin, you're going to have to leave. All right, find dy dt. I don't write dy dt a lot because that takes too much time. I like to be fast, I like to be efficient. So in my work, instead of dy dt, what do you think you're going to be looking for? Y prime. Okay, I'll be looking for y prime. So in my mind, I'm getting everything loaded. I know x prime equals 4. I know x equals 2. I know y equals -1. Don't even try to theorize what's happening on a graph just yet. Let's just worry about the algebra. We'll worry about the graphs later. Okay? So here we go. X cubed minus 2y squared plus 5x equals 16. Ah, let's do something easy. What's the derivative of 16 according to time? 0. That's pretty nice. Got it right. I'm going to make the following changes. Remember, I did this with implicits. If it's x cubed, you can't treat it just as x because it's not dx dx, it's dx dt. There's going to be an x prime. Just like there was with y primes and y squareds. This one, this 5x, that's going to be okay because we know it's going to be 5x prime. Okay? So, the key is it says a function of time. The sad part about this topic being stuck here at the end of the chapter is when we go back to doing derivatives in the very beginning, like x cubed plus 5x plus 7, people write 3x squared x prime plus 5 plus 0. You only have x primes when you're doing it with a function of time. The previous 7 sections didn't have time in it. So what I'm trying to say is if you're taking the derivative of cosine of x, y equals, the answer will still be y prime equals negative sine of x. It won't be negative sine of x, x prime, because you're taking the derivative with respect to x. Isn't that right, Katie? Thank you. All right. Oh, great. Okay. What's the derivative of x cubed according to time? Yeah, 3x squared x prime. Who said x to the fourth? No, you got to subtract one when you take the derivative. 3x squared x prime. Good. And then the derivative of 2y squared will be? Yeah, 4y prime plus 5x prime equals 0. Okay? So there we are. 3x squared x prime minus 4y prime plus 5x prime equals 0. And I told you this in the last section. I put numbers in right away. It's mainly from this. I don't have to solve for y prime because there's a lot of things there. I just want to get to the numbers right away. So you'll see me in place of the x, I'll put in a 2. In place of the x prime, I'll put in a 4. In place of the y, I'll put in a negative 1. In place of y prime, I'll put in nothing. I'm looking for y prime. And in place of the x prime, I'll put in 4. Okay? There's a lot of things to put in this equation. So, I put in all the values. And don't forget, I am looking for y prime. Let's see, 3 times 4 is 12 plus, 48 plus 4y prime plus 20 equals 0. You get through the calculus to the algebra pretty quick when you're doing related rates. I'll spend a couple days on this, and then we'll get ready for your test. Okay? Ready to move on? Is it? It is negative 17. Nice. So I just put from start to finish on there. I don't think you need all that, just the last couple. Any questions? Great. I think we're ready to try another one, don't you? Absolutely. I'm trying to think of a better example than a ladder and a house. Maybe one will pop up. Here we go. This is like your first homework question in your book. If s equals z cubed and dz dt equals negative 2 when z equals 3, find ds dt. I'll give you, you can do this one on your own. Give it a shot. All right, the derivative of s is obviously s prime. Derivative of z cubed? Yeah, 3z squared z prime. Good. Put the numbers in. That should be s prime. Should be s prime, and s prime equals negative 54. How'd that go for you? Pretty good? I wish the whole test was like this. Yeah, this is like the first problem in the section. So this is like the second problem in the section. Negative x squared y squared minus 4y equals negative 44. The only thing that makes it hard is all the negatives. I am going to invoke the theory of the fort for the first one. Because you're going to have to do the, what rule? Product rule. Maybe you can handle the negative with the x squared. Yep. That would change the rates. Right. Negative x squared y squared minus 4y equals negative 44. Right. When you do that, instead of 2x, you're going to have 2x x prime in your answer. Let's see. 2x x prime y squared. X squared 2y y prime minus 4y prime. Yeah, and then I think you're ready for numbers. The product rule looks different because you have that x prime in there now instead of a 1. So it's going to look odd. Yeah, looks good. I'll probably put numbers in. I know some people like to work it all the way down, but I like to put numbers in ASAP. So you put in the negative 3, put in the 5 and the 2, the negative 3 and the 2, and the y primes are left. And it looks worse than it really is when you put something in like that, because you have a calculator. I mean, plus it's simple arithmetic, negative 6, negative 30, negative 120. So that doesn't go too bad. And then you got another 9, 2 is 18, 2 is 36. Yeah. Well, when I run it through, I haven't run it through yet. But yeah, you're right. So it's going to be negative 40. Oh, I think it's going to come out now as a fraction now. Yeah, so it's going to come out to equal 3, isn't it? Nice. Look at that answer, 3. It is. Fantastic. See, somebody told me once these problems are like building a house of cards, and you get so, and all of a sudden you realize that you forgot to do something, there it goes. You just pick yourself up and you keep going. Perseverance. Perseverance goes a long ways in calculus. Yeah, that's fine. You counted for it that way. Just as long as it wasn't negative x all squared, but negative x squared. That's fine. Yeah. Yes. I don't know. With all the negatives? Negative, negative will be a positive. 2 and 3. Okay. All right. See, that's not so bad, especially when we go through the rest of the chapter. Ha ha! This is why this was stuck in my head. A 20-foot ladder leans against a vertical building. If the bottom of the ladder slides away from the building horizontally at a rate of 2 feet per second, how fast is the ladder sliding down the building when the top of the ladder is 12 feet above the ground? You just got to love this question. If you can come up with a picture, you can come up with a relationship, you can take the derivative and solve it. First of all, it's going to be, 20-foot ladder. Slides away from the building at a rate of 2 feet per second. Three? No. 2 works out good. This is, I'm going to let this be the letter A, C, and B. Okay? You can use X, Y, and R if you like. You can use A, B, and C. You can use H, J, and K. But I'm just trying to equate this. C equals 20. So I went horizontally at a rate. So A prime is going to equal what? 2. I'll probably use X on the next slide, but that's okay. Get the idea. How fast is the ladder sliding down? So B prime is what they're looking for in the answer, right? Yeah, that's what they're asking for. When B equals 12 feet. When B equals 12. Okay? So it's going to look something like this. I'll use X and Y's. Sorry. So there's a bigger picture of it. Y is 12. What's Y prime if X prime is 2? And R is 20. So I used X, Y, and R. This might be a good section to take a look at the student solutions with the pictures and the equations. But anyway, what else do you know about this? There's one piece of information left that you have to figure out. Yeah? Yeah, A or X is equal to what? Yeah, 16. It's a right triangle. You're going to have to do the Pythagorean theorem to find this horizontal length. Okay? So, x squared plus y squared equals r squared. No surprise there. I put in the 20 because it's not changing. Right? Yep. Oh. So the 20 is not changing. The x and the y are. That's why I get this nice little derivative. 2x x prime plus 2y y prime equals 0. How you doing so far? Pretty good? Well, I think it's equal to 16 because it's like a 3, 4, 5 multiplied by 4. Yeah, then you put in the 16 for the x and put in the 12 for the y, and you work it out. X is equal to 16 feet because it's a right triangle. Should the answer be positive or negative? Is it going up or down? Negative. There you go. Nice. It should be negative. It's going down. Why is the other one positive and it's going right? Well, it's getting bigger. The distance is increasing. The distance vertically is decreasing. And, y prime is a rate. So, I don't know, negative 8/3 feet per second. Whoa. Yeah, so you're dropping, so you're kicking out 2 feet and you're dropping 2 1/3 feet. So you're going down faster than you're going out. The ladder, it's a right triangle. they're not at equal points on the time. One's only 16 feet away and the other is 12 feet away.
Yeah, but still.
Still what? They don't have to be equal.
If it went down an inch, you can't just leave the bottom station.
It's not an isosceles triangle. The angles aren't the same.
Like if you get a ladder, like you're swinging against the wall,
Yeah?
you hold the bottom, you know,
Yeah?
and then just slide down the wall. The bottom, if it goes down an inch, the bottom has to go out.
Oh, no. Uh-uh. Huh?
How does that physically work then? Because if you have something leaning up against the wall, the bottom can't move out, the top can't move in.
Right.
But that doesn't.
Yeah, the bottom part is picking up 2 feet that way. That's how fast it's changing. It's not the distance that's changing, it's how fast it's changing. This is going out 2 feet per second. This is going down at negative 2 1/3 feet per second. So it's going faster down than it's going out at this point in time. So that's not how much it's changing, it's how fast it's changing. So you're going to feel it going down faster than going out, which I would probably agree with. You're going to be a lot more scared about going down than you are going out. But, I don't know, we asked Mr. Glazier also. Hey, 4 questions. The mining tools. How timely was that the first time we did that? Got home, there's a picture all. There's funny stories about that too. There's a lot of funny stories about that. I mean, everybody's safe. There were some like interesting storylines I found funny. Ready? How much time we got left? Oh, we got plenty of time. All right, this one should be like a quick hitter. No thought required. This lesson introduces what type of differentiation? Chain rule, explicit. It is C, related rates. Oh, last year people miss out all the time. You know why? They'd pout. They put their arms folded together. They wouldn't say anything. No, I actually was taking these for grades last year. Here we go. Give this one a shot. X squared plus y squared equals 13. This is one of those feel good about yourself problems before you leave. Instead of feeling like you've been beat up the whole period. What'd you get? What'd you get? Ooh. 2 people, 2 different answers. Nice. Oh, one answer's gaining steam now. Where are you at? Oh! I got a positive 2, not negative 2.
Did Mark get it right?
Mark went with Jimmy first.
Why did you do that?
Okay? How many people got 2, by the way? Good. After you changed it, excellent.
Did you change it before or after he told you it was wrong?
After. No, I just said it was different.
Oh, it's different.
This isn't a doing question. This is a thinking question. You're going to have to figure out which equations to use to relate the rates. For example, a water tank has the shape of an inverted right circular cylinder. If the water is being pumped out, what equation would you use to solve the problem? Would you use the surface area of a cone or the volume of a cone? B, and what is the volume of a cone? Right circular. Oh yeah, it should be a right circular cone. Trick question. Should be a cone. Sorry. 1/3 pi There. You don't need that for your homework, the volume of a cone. Make sure you know what it is. That's why that question's there.
What did an inverted cylinder be?
A cylinder.
Wait, this is for cylinder?
This is for a cone. A cylinder is pi r squared h. There's no 1/3.
Yeah, it looked nice.
But you're going to need that equation for your homework. And when taking the derivative of all rates, all variables are differentiable with respect to time. Yeah, I'd go with true also. Okay? There you go, page 158, 1 through 13 odd. You have tests coming up next week. Make sure you get some things taken care of. And on Monday, we'll probably do a 5 for 10. All right? I know, I think it is nice. The previous section? Yeah, 3.6. No, it'd be 3.6 or 3.7. All right.